A Milli finite state machine is a model of computation which describes how an output is obtained given an input and a current state. So the output will depend on the input and on the current state. This abstract machine can be in one of a finite number of states, and the state the machine is in at any given time is called the current state. It can change from one state to another, and this change is called a transition. As an example of these machines, we can think of a machine whose output depends not only on the input but also on the current state. Let's think, for instance, an elevator. Let's say that an elevator is a machine that goes up or down. So the outputs will be going up or going down. And the inputs will be the buttons that we can press, right? So then think, for instance, if you press the button for third floor. So where the machine is going to go, up or down? Think for a moment. Well, we don't know, right? It does not depend only on the input, on having pressed third floor. It depends also on the current state of the machine. It will depend on what floor the elevator is currently. So currently the elevator is at the first floor, so then we'll go up to get to the third. But it currently is in the sixth floor, so it's going to go down to go to the first. So we see here an example in which the output depends not only on the input, on the button that we press, but also on the current state. More precisely, a finite state machine consists of three sets. One is a set of states, also a set of inputs, and a set of outputs. So these three sets and also two functions. These two functions are going to be the transition function, that what it does is take a state and an input and associate the next state. For instance, in the case of the elevator, if we take as a state the current state, the floor 6, let's say, and we input here the button for the third floor, the next step is going to be the third floor. So this transition function is going to associate, for instance, to the state 6th floor and input button for the third floor, state third floor. And then a output function that is going to take again a state and an input, but is going to associate an output. So in the case of the elevator, for instance, if we input here as before the 6th floor and the button for the third floor, the output is going to be going down. And finally, an initial state that is given also as a data of a finite state machine. Let's see an example where we can identify all these things. So, let's consider the example of a vending machine. So, this is a vending machine that accepts the following coins: 5 cents, 10 cents, and 25 cents. Only these three coins. When a total of 30 cents or more had been deposited, so the machine immediately returns the amount in excess of 30. When 30 cents have been deposited and after any excess is refunded, the customer can then push a red button and receive an apple, or push a yellow button and receive a banana. And the machine resets afterwards. So, this is our machine. So we have here 3 coins. These are the only things that we can put here. We will obtain our change here, and we will obtain here an apple or a banana. So let's think for a moment what would be the states of this machine. So when we put 5 cents, when we put 10, when we put 25, I mean the only things that we can put into this machine when we press the button, the red button or the yellow button. So what are the states that this machine can get in? Well, let's say that we are going to consider as the initial state when the machine has 0 cents in it. So after that, when we put 5 cents, when we put the coin of 5 cents, the machine will be in another state. Let's say inside is going to have 5 cents already. Or it's possible also that this machine has 10 cents inside. It could be that we just put a coin for 10 cents, or it could be that we put 5 cents, but this is a possible state, right? And think all the other possibilities. I mean, considering that we have only these 3 coins to put into the machine, so the 7 possible states in which this machine can be are these ones written here. Observe that we can have 30 cents, right? Eventually, there are many combinations that will give you 30 cents, but we cannot have more than 30 cents inside of the machine since this machine resets after that. Okay, so this would be then the first, I mean, the set of these elements would be the first set, the set S of the states in this finite state machine. So it's a finite set, right? Have only 7 elements. The set of inputs. Well, the input is all what we can input in this machine. So we can either put this coin, this coin, this coin, press this button, or press this button. These are all the things that we can do in this machine. So the set of inputs is going to be this coin, this coin, this coin, or this button and this button. So this is going to be the set of inputs. And what are the outputs that we can get from this machine? Well, you may get an apple, or you may get a banana, or you may get nothing. Or you may get also the change here. And how much change you can get? Well, considering that you can put only these ones, and as soon as you get 30, will give you the excess. What are the possible excesses? Well, the set of outputs are going to be either you obtain nothing, this is one possibility, or you obtain 5 cents as a change, or 10 cents, or 15 cents, or 20 cents, or 25 cents. So check that these are the only possible changes that you can get. Or you may get a banana or an apple, right? So this will be then the finite set of outputs. So let's think of a concrete possibility here to find out the functions, the transition functions. So suppose that we want, this is just an example, suppose that we want an apple and we have 2 quarters. So let's think how this machine is going to work in this scenario. So we start with the original, the initial state, that is that the machine had 0 cents. So then we put in the machine 25 cents, right? We said that we had 2 quarters. So let's put 25 cents in the machine. That will be the input, right? That we put 25 cents. And so what will be our next state? So if we have 0 and we put 25, so then inside the machine now there are 25 cents, right? So that will be that we are at the new state is S5 at this point. Okay, so that will be the new state is S5. And what will be the output in this case? So the output will be in this case, what do you get? I mean, if you put 25 in this machine, you get nothing, right? So let's put N, so we get nothing. That will be the output in this case. So observe the 2 different things that we have here. One is the next state, and another thing is the output, are different things, right? Okay, so now we are in this situation, we still want our apple here. So now the current state is going to be S5, right? So because that was the next state here. So we have 25 inside of the machine. And then we put another input. We put 25 cents more because we have 2 quarters in this case. So we're going to put another 25. So to what state we pass now? So think for a moment, we have 25 in the machine, we put another 25, we're going to have 50, right? But this machine returns immediately the excess. I mean, never gets to get 50. The maximum that can get is 30. So that means that our next step is going to be the one that had the 30 cents in. Is going to be S6. And also the output, we are going to have here some change, right? Because immediately the machine returns the excess. So the excess, if we have 50 and excess from 30, will be 20 cents, right? So we are going to get 20 cents as an output. And now our current state is going to be then S6, right? Because that was the next state from the other step. So we have 30 cents. So what are we going to put here? Are we going to keep putting money? No, we have already enough money. So we are going to press the red button, right? Because we want an apple. So we input the red button. So this one is going to be our input. What is the next state? Well, considering that this machine reset, the next step is going to be this one, right? It's going to be S0, so it's going to begin 0 cents inside. And what's going to be the output? Well, the output is going to be finally the apple. So this is then the output. So we repeat again. So if the current state is 0, we put 25 cents and we pass to the state S5 and the output is nothing. So when we start in that state, I mean the next state becomes the current state, we put another 25, the next state is going to be S6 and the output is going to be 20 cents. And so we start with the current state now being S6, we press R, the next state is S0, goes back to the beginning and the output is an apple. So let's see how we are going to organize. This is just one particular possibility, let's say, right, that we want an apple and having 2 quarters. But we can figure out what happened with all these possibilities. I mean, what if we put 5 cents and so we put 10 cents and so we put 5 cents again? So let's see how do we organize this data in a table. This is what is called an state table. In a state table, we are going to put in the first column all the possible states of the machine. So in this case, the seven states. In the other columns, we are going to put the next state and the output. These actually are like 2 independent tables that are put just side by side. In the first one, in the next state table, so we have for the different columns here, different inputs. So that's why the word input here. These numbers here are just all the possible inputs. In this case, the 5, 10, and 25 coins, and the button for red and the button yellow. And so you are going to fill this table here by putting here just what is the next state. So that will be the transition function f. So what does it mean? So for instance, if you are in the state S0, I mean when there are 0 cents in the machine, and you put 5 cents, what is the next step that you get here? Well, it will be like the 5 cents state, which is S1. So if you are in S1, and you still put 5 cents. So remember that S1 is the one that already have 5 cents. If you are putting 5 cents more, you are going to get to the state of the 10 cents, which is S2. And so on. So complete all the table here by putting what is the next state once that you put, for instance, this input. And you do the same with all the other inputs after that. But before getting to the other inputs, let's see what happened with the other side of the table. The other side of the table, instead of putting here the new state, that is what you put here, you're going to put here the output. What does it mean? So if you have the state as 0 and you are putting the input 5 cents, what is the output that you obtain? Well, you obtain nothing, right, if you are putting just 5 cents. And then if you are in S1, that is when it's already 5 cents in, and you still put 5 cents, so what's the output? Still nothing. I could say here in all this column is going to be all nothing except at the end here, when you have S6. Remember that S6 is when you already have 30 cents inside of the machine. So when you have 30 cents and you put 5 cents, what's going to happen is that these 5 cents are going to come back, right? Because any excess to 36 will be returned. So that's why the output here is 5 cents. And so on. You continue to do all the entries of this table in that way, and that should be the table, the complete table that you obtain. For instance, let's just check any entry. For instance, S3. I remind you that S3 is when there is already 15 cents in the machine. So let's suppose that we are in the state in which there are 15 cents in the machine, S3, and we press, let's say, R. So what is the next state? Well, S3, right? Because we are not putting more money here, so we are going to be still being at S3. And what will be the output if we press R? I mean, we have only 15 cents. No matter how many times we are going to press R, we are going to obtain nothing. Okay? So only if we have the 30 cents like here when we press R, so then we are going to get the apple, and when we press Y, we're going to get the banana, but only when we have already the 30 cents. Well, check all this table. Be sure you understand all the entries here. And we are going to see next another way to organize actually this data. The same data, instead of being organized in a table, can be organized in a digraph. So the digraph is going to have as nodes the states. So let's put all the different states as nodes. This one that have an arrow like this is the notation, the specific notation in this kind of diagrams that are going to be called state diagrams to identify the initial state. Remember that the initial state is part of the data of the problem, so you have to say which one is your initial state. So after writing the states as node, how we are going to write down all the other data? Well, we know that from S0, the next state is S1, is we put 5 cents. So we're going to put an arrow from S0 to S1, but label with the input 5 cents and the output N. So let's say S0. So what this means? What means all these arrows? So let's start with this one. This is the one that I just said. So to be an edge between S0 to S1 means that S1 is a next state. But it's a next state when I put what input? Well, the input 5. And when I put what output? The output N. So each of these arrows are going to be read in the same way. So this one, I read it as the next state to S0 is S2 when I put the input 10 and I obtain the output N. So S0, which is to have 0 there, so if I put 25 cents here, I go directly to the state S5, which is the one that has 25 cents in. And what is the output that I obtain? Nothing. And what if I put the input Y? I mean, if I press, I am in the state 0, right? The machine has 0 coins, 0 cents in it. And I press the button yellow. What is going to happen? Well, the output is going to be nothing, and the state is going to be still a 0. I mean, does not change the state. So the loops are when it does not change the state, right? So the state from a 0 is still a 0. Same thing will happen if I press the red Apple button. So it's not going to happen anything. I will obtain nothing and will not change the state. See that the number of arrows that you have coming from S0 are given by the input, right? So this is the one from the 25, 10, 5, Y, and R. This was exactly the set of inputs. And then you have to do that with each one. So S1, so you will have all your arrows depending on what's the next state, what's the input and the output. And so at the end of the day, you will have this one will be for the node S6. So you can see that if you put here, when you are in S6 that you have already the 30 cents, if you press Y, then you do get a banana and the state becomes a 0, resets. And then you continue to fill the same for all the other nodes, and this should be then the final diagram for this table. Be sure you check all the arrows here. Be sure that you understand why each of the arrows, what's the label of each of the arrows. And that will be the state diagram corresponding to the original state table.